Okay, let's try the next trigonometry question. Ooh, looks like another Pythag trig question here because you got your sine alpha, divide by 5. You know that it's positive 3 over 5, but you know it's between 90 and 270 degrees. So if it's positive, it can't be the first quadrant. It must be in the second quadrant. This one we know cosine's positive 12 over 13, but it's got to be between 180 and 360. So that must be in the fourth quadrant. And that's what Mr. Autry has done here. That's right. Cosine is between 90 and 270. 90 and 270 down here must be where tangent's positive, must be right here, not tangent, sine, I mean. And look, opposite over hypotenuse is 3 over 5. Use Pythagoras, you get it's 4, but you're going to the left, so remember it's minus 4 by Pythagoras. And there's your cosine, must be, like I said, in the fourth quadrant. And you go 13 squared minus 12 squared, square root it, you get minus 5 by Pythagoras. And there we go. We've got that. Now it says, what's sine alpha minus beta? Well, you've got a formula sheet that tells you what sine alpha minus beta is. I don't know if they give you a mark, but if you write down sine alpha cos beta, you've almost got your answer. Now, you know that the sine of the alpha is 3 over 5. And the cosine of beta, you know, is 12 over 13. You were given that. Just put it in. But you know the cosine of alpha must be minus 4 over 5, adjacent over hypotenuse. Sine must be minus 5 over 13, minus 5 over 13, opposite over hypotenuse. Just put those numbers in your calculator, or you could probably know what 5 times 13 is 65. The answer is going to be 16 over 65. Now, there's two ways to do this question. Some people, when they see the cosine of 70 degrees equals p, there's a trick like this, and you make a triangle with 70 degrees, and you go p over 1. And then you don't know what this part over here is, y, but it's going to be the sine, opposite over hypotenuse here of 1. It's p squared, 1 squared minus p squared. So the square root of 1 minus p squared, that's what y is. But you can get it another way. Some people like to do it this way, where you go sine squared plus cos squared equals 1. But we know what cos squared is. It's just p squared. And we just subtract it from both sides, take the square root. Look, we get exactly the same answer. Now, express the sine of 140 degrees in terms of p. So 140 degrees, oh, this is a trick. There's a thing called double angle identities that we've learned in grade 12, and you go 2 times 70 is 140. Now there's a formula that says the sine of a double angle here of 2 times an angle is the sine of the angle times the cosine of the angle. Okay, 2 times the sine times the cosine. And that's, now what's the sine of this? It's root 1 minus p squared. And this should be the cosine of 70. It's a little typo there. It equals p. It's sine 70, cos 70. So that little thing there should be a 70, but there's your answer. And then the whole thing just kind of works out.